So, I'm very happy to be here. I'm very excited to talk to you about natural language processing. And the subtitle of this talk means that I'll try to give a more general overview of tools and techniques that you can use. So I won't delve into details that much, but rather give you something to start with and to look for more information.
But before we go forward, just welcome Sebastian on the stage.
Thank you.
Okay, stage is yours.
Okay, I'd like to start with an introduction, and let me first introduce myself. So my name is Sebastian Dziadzio. I come originally from Krakow, but I live in Munich at the moment, and I work at Clicks, which is a cool startup, and we're building a private browser. So a browser with built-in anti-tracking, anti-phishing, and a private search. So if you use this cool thing called the internet, but are not a fan of sharing your personal data with big companies, boy, do I have a product for you. Also, recently, we've acquired Ghosttree. Some of you might know it's an anti-tracking extension, and together we're working on building the best anti-tracking technology. So I have a couple of those guys. Let's say if you, I don't know, ask a good question, you get one. I define a good question as one that I can easily answer. Yeah, I have plenty of those. You don't have to ask a question, just come, say hello, and you'll get one. Okay, so if you feel a sudden urge to tweet during this presentation, this is my rather unimaginative handle. Also, if you want to say hello after the conference, it's a good way to contact me. Now, what is natural language processing? It's very hard to define because it's a very general field of knowledge, but if I absolutely had to, I would say this is a set of techniques and methods that let you transform raw language data into a machine-readable representation, and the other way around. So for example, Martin told us about machine translation, and it's a good example when you're doing both things. So you start with raw data in one language, you go into an intermediate representation, and then you generate output in another language. Why is natural language processing important? Well, every day we produce a ridiculous amount of data. Much of the data is actually language. We use messengers, we use social media, and so on. So extracting valuable information from that unstructured data is a very useful thing to do. And it is useful for consumers because you can have products like Amazon Echo or Google Home, which has been promised by sci-fi for a long time. And finally, we're starting to deliver it. So you won't get a jetpack anytime soon, but you'll be able to talk to your microwave if you want to. Now, why is natural language processing hard? Well, language, by natural language, I mean the language we speak, the language we write, the language we sign, and it is a natural phenomenon, which means that it evolved. And with every product of evolution, it is more about being good enough rather than perfect. And language is far from perfect. One of the most annoying features of language, as far as NLP is concerned, is its ambiguity. So language is naturally ambiguous. For example, you can have something like semantic ambiguity, when the same word can mean different things. Or you can have phonetic ambiguity, or syntactic ambiguity. In this case, in the first sentence, time is the subject and flies is the verb. And in the second sentence, fruit flies are the subject and like is the verb. So it's even hard for a human to process instantly, and it's very demanding for a machine. Now, language evolves and it continues to evolve, which means that no dictionary will ever be exhaustive. And Oxford Dictionary is updated every year, and these are the words that has been added this year. And I think they speak volumes about the time we live in. We have worsters, which I assume is millennial for worst, hate monger, post-truth, and pogonophobia, which is the irrational fear of beards, assuming there could be irrational fear of beards. Now, language is very flexible, very unstructured, but on the other hand, there are implicit rules that we use, and sometimes we don't even realize the rules are there. For example, English has a very constrained order of adjectives. So here we go. There's opinion, size, age, shape, color, origin, material, purpose, and then noun. So you can have an ugly, large, old brown English tweed hunting jacket somewhere in your wardrobe, or organize a big, fat Greek wedding. But if you use any other permutation, to a native speaker, you're gonna sound a bit like this famous little green Jedi Master. Now, some languages are harder than others. Every language has its rule. I won't attempt to read this word, but it's a real one. And knowing those rules is essential for effective language processing. So on one side, language is unstructured and flexible. On the other side, it's very constrained in some respects. Fortunately, we have a lot of tools and methods to deal with that. So I'm going to give a quick overview of the libraries, methods, tools you can use, and outline the process of approaching NLP problems. So above you can see the general pipeline of approaching most natural language processing problems. Of course, I cannot give you a one golden rule to approach everything. Speech recognition is going to be different from text classification, and text classification is going to be different from machine translation. So there are many aspects of NLP, and each is going to be a bit different. But you usually start with a data set. So you need to get it from somewhere, and there are plenty of resources you can use. Data repositories such as Kaggle or data.word, they have already Python SDK, so you can access it directly. Also, there's this GitHub repo on NLP datasets, so you can use that to find your dataset. If you're looking for linguistic resources, usually a good place to go is a website of an academic team, a university, and so on. So, for example, Stanford NLP has a ton of resources for English mostly. Then if you're interested in Polish, there's this second website. And also you can search GitHub. So there's this repo called Awesome NLP. You can also look for, say, Awesome Polish NLP. And you find resources for Polish and other languages as well. Now, you're free to build your own data set, of course. Although it's a bit demanding with some NLP problems. For example, if you want to do text classification, it's a supervised learning problem, so you need to label the dataset, which is generally difficult and requires a lot of effort. But Twitter, GitHub, or Wikipedia have APIs you can access, and you can build your own dataset, which is a very valuable contribution to the academic community and community of programmers as well. Second thing you usually do is you transform the data somehow. So this is just text transformations. So you can normalize text, meaning you strip off emojis or hashtags or user mentions, anything you don't need for the particular tasks. So it obviously depends on the problem. Then you can do stemming or lemmatization, which basically reduces your dictionary. And then you can add some information, like part of speech tagging has been shown quite recently to improve neural machine translation. So sometimes adding this information is also effective. Now, tools, you can use plain Python, so you can go quite a long way with regular expressions in general, and functions like lower or strip or split and so on. Unix command line is also quite useful for this pre-processing part. Then you have NLTK for stemming or lemmatization is better for educational purposes. I wouldn't use it in production that much. A nice modern alternative is Spacey. Now, this is what tweets look like in general. So this is an example from one of my side projects. And you can see that you might want to need to strip the user mentions, to strip some punctuation, emojis, and so on. Other text can look like this as well. So there's no one regular expression that will work every time. This is an example of stemming and lemmatization. I would generally recommend to lemmatize words. This is a quote from Monty Python. And in the middle, you have the lemmatized version, and then you can see that stemming is generally more brutal. So you just chop off the endings, and it's rather simple algorithm, and lemmatization is more linguistically informed. So it's a bit more sophisticated, of course, more time-consuming as well. Now, every task can be demanding. For example, this is a perfectly ordinary sentence in English. Now, you might not know that buffalo has 3 meanings. One is the name of a city in the US, I think, and then the name of the animal, which is technically a bison, and also a verb, which means to intimidate. So parsing a sentence can be difficult. Now, encoding is the process of transforming the data from text to some numerical representation. And there's plenty of ways to do it. You can use, for example, TF-IDF or one-hot encoding. If you want to hang out with the cool kids, it means you want to use word embeddings or some variant of word embeddings, which is a very clever algorithm that lets you go from text, from words, to real valued vectors. And it has this interesting property that words which are similar semantically are going to be mapped close to each other in this high-dimensional vector space. So this is a very useful feature, and you can go a long way just using a pre-trained word vectors, and then building a simple classifier on top of that, or using any linear models just with those pre-trained embeddings. If you want to train your own, you can do it, of course. So there's GenSim, very nice topic modeling library, and we have the creator of GenSim giving a keynote tomorrow. There's FastText from Facebook, which uses slightly different algorithm, takes into account subwords. So it's more morphologically informed. And then there's GLAF, which builds those vectors using matrix factorization. One example is information retrieval at clicks. So the way we do it, our index is basically a dictionary that maps queries to websites. And when we get a new query from the user, we want to find similar queries in our index and serve the specific website. And the way we do this is we map it into a shared embedding space, and then we look for nearest neighbors. So it's an extremely simple approach. Works surprisingly well for this task. Of course, it's not an exhaustive search. We use an approximate algorithm. There's a library from Spotify which is called Annoy, and it enables you to look for approximate nearest neighbors. I'm sorry for my voice. I'm a bit sick. Okay. Now, if you want to, of course, it's an optional step. Once you have this representation, you can visualize it. And there's a talk tomorrow about visualizing word embeddings, so I won't do that. Instead, I'm going to visualize TF-IDF vectors. So I trained them on Project Gutenberg, and we're going to see that in a minute. Of course, if you want to visualize high-dimensional space, you're going to first want to convert it to more human-friendly number of dimensions, such as 2 or 3, and then you can visualize it. So to do it, you can use PCA or TSNE, so algorithms will that let you reduce the dimensionality of the space. And you can use scikit-learn for that, and then matplotlib for visualization, It's very simple. So the example I told you about, I just trained TF-IDF vectors on books from Project Gutenberg, and then you can visualize it using the word cloud package from Python. I think the bags for the conference were also designed using that library. And then, can you guess the book? Not too difficult. Yes. And then it's a very simple approach, but you can already extract some information from it. For example, on the right, you have the first story of Sherlock Holmes and Dr. Watson. And you can see that Holmes is very prominent in it, and you can't even find Watson. And then there's the Hound of the Baskervilles on the left, and then you can see Holmes, but Watson already starts to appear, so the relationship is developing. And you can also use this dimensionality reduction. So these are TF-IDF vectors that are mapped to a two-dimensional space. And you can see, for example, that Shakespeare plays are very close to each other. There's a strong cluster near the top of the picture when you have Jane Austen and Charlotte Bronte very close to each other. On the right, you have the philosophers, so there's Plato and Aristotle. In the middle, you have a poetry cluster, and then bottom right, there's Dostoevsky, sad and alone in the corner. So it's a very simple algorithm. You just construct TF-IDF vectors, and then you visualize it in 2D. You can already see some interesting relationships. Then once you have the embedding or other form of real valued representations, you can train a model. And you can use basically the old school machine learning models. But again, if you want to be cool, then you're probably going to use deep learning. And there's plenty of architectures, like for machine translation, there's this sequence-to-sequence architecture. For finding similar items, there's this Siamese architecture. There's plenty of options there. One of the basic building blocks is our recurrent neural networks, in particular LSTM, and also the bidirectional variant. One mechanism that I'd like to draw your attention to is attention, and that enables you, first of all, it will improve the performance of the model, but also it lets you inspect the model a bit. So we can visualize which parts of the data the model uses to solve a particular NLP task. These are tools you can use. So for those old school models, I mostly use scikit-learn. And for deep learning, I prefer Keras because it's very easy to learn. Spacey has a ton of pre-trained models as well, so it's, I would say, very useful. One example of a side project I did was hate speech detection from tweets. And basically, I trained a deep LSTM model and also a very simple linear model on top of fastest embeddings. And it turns out that the simpler model is almost instant to train, but the performance is only slightly worse. So it didn't really pay off to use the more complicated version. I'd like to propose some best practices. Of course, these are best practices according to me, my personal experience, and the experience of people I worked with. And the first thing I want to say, it is very important to define the problem you're trying to solve. So there are three main components of any ML task. First, the actual task, then the data you're using, and then the metric you're using to see how well you're doing. And depending on how you choose any of those, you're going to end up with a completely different problem. So pay attention to how you define the task, what data you use, and what metric you use to score your model. Second thing are assumptions. So you know that every model is wrong and some models are useful. And it's very important to remember what assumptions you're making before you even build the model. So how you preprocess the data, what information you retain, what information you reject, and so on. And for me, the most important part is motivation, so keeping in mind what question you're trying to answer, who are the stakeholders, who are you going to report to, and what are you actually trying to solve. Second thing is to inspect the data, and there's a couple of problems you can bump into. First, data can be just too noisy to learn anything, and that may not be your fault, because a lot of data sets are actually crowdsourced, and annotators are human, they make mistakes, so then they can introduce a lot of noise to the data set. Second problem is data set can be ordered, so remember to just shuffle it randomly before you start training it, and especially before you split it into train and test data set. Then imbalance, this is important for classification problems. So, for example, in this hate speech detection problem, it may be hard to believe, but the majority of tweets actually do not contain hate speech. So it's important to keep in mind that the classes are never going to be to have the same number of examples in your data. Then again, you can simply have too few examples to learn anything, so the data might be too sparse. And also, if you're working with different languages, you're gonna bump into problems with encoding. Avoid reinventing the wheel, so I gave you some examples of libraries you can use. If you absolutely can't use other people's code, at least reuse your own. So extract the functions you use often into modules and then reuse them for other projects. This is my personal advice, so choose the simplest tool, the simplest method possible that will solve the problem. So Catherine told us about this Kaggle approach, when you basically build an ensemble of 1 million models and then you can't really use that because you can't interpret it. So start very small, start with a data set you know, or start with a model that you can control and the model you can understand and the model you can build on. So once it breaks, you're gonna see it. You're gonna know at which point something went wrong. If you start with a very complicated model on a data set you don't know, there simply will be too many parameters and you won't know what went wrong. And then if you use other libraries, if you use other people's code, don't be afraid to open the black box, don't be afraid to look inside, to inspect the code and to actually understand how they do what they do. So then the technical advice, I do a lot of work in the terminal, and I think it's a great tool for preprocessing, organizing your data, and so on. But the learning curve is a bit steep, but it pays to actually know the Unix utilities well. Final piece of advice, get your work out there. So if you do something like writing your own Linux kernel, it's a great conversation starter, but in some circles. It's also a great conversation stopper in most circles. But if you work with machine learning or with NLP, it's very easy to explain the problem in layman's terms. So take advantage of that. Write a blog post, add a README to your personal project. And I want to leave you with the words of Andrei Karpathy, whose blog post introduced me and I'm sure many others to NLP. And he said, do good work, communicate it properly, people would notice, and good things will happen. Thank you.
Sorry, thank you so much. We have time for a few questions. There's one in the back.
Okay, so I have a question. I don't know if you will be able to answer because it is about the information retrieval that you talked before. Yep. Because this is pretty much the task of you your search engine to provide results. So could you elaborate a little more on the information retrieval you used?
So the way we do it is we have our own web index that I think is about 2 billion pages at the moment. We focus on the German part of the internet, but we're already expanding to other markets. And what we have, I'm going to simplify it very much, but how it works is we have this index which are queries we've already seen, and they point to websites. So when we do the first we want to fetch the first, say, 10,000 pages to serve a particular queries, and then we re-rank it. And finally, we serve just 3 queries. So the way we do that first step is we map this user query and all the queries in our index to a shared embedding space, and we use fasttext for that. And then we search for nearest neighbors using this approximate nearest neighbor algorithm, which I won't explain now. But the library is called Annoy. It's from Spotify, and there's a very good explanation there. So it lets you find nearest neighbors in a very large data set. And usually the number of similar queries we would consider for that initial step would be like 4 million. And then we want to find nearest neighbors in that. So we wouldn't be able to find it in real time quick enough. And latency is very important in information retrieval because you don't want to annoy the user, basically.
Yeah. So you work around pretty much the cold start with comparing the queries, right? So you don't start from the scratch. And did you do anything with indexing, for example, the contents when you do the re-indexing or researching? So you have some similar queries. Is anything happening to the content on the sites, or is it just a next step?
I don't work at search, so the short answer is I don't know. But I think it's based on user queries only at the moment.
Okay, thank you. Anyone else? Or, yeah.
Are some languages easier to process than the others, or
Yes.
NLP is language agnostic?
It's definitely not language agnostic. So for example, this lemmatization or part of speech tagging is especially important for highly inflected languages like Polish. So I recently tried to translate a sentence in Google Translate, and in Polish it was jest informatyczką, so there was no information about the pronoun. And this translates to English as she is a computer scientist, but Google translated this as he is a computer scientist. So a bit awkward, but it probably comes from the bias in the data. So you want to introduce that information because some languages have mechanism that do not exist in other languages. Like in English, you usually specify the gender in the pronoun, right? And in Polish, the information is in the verb or in the noun. And in general, highly inflected language are more tricky, and I think the next presentation is exactly about that.
Okay, thank you so much for your talk.
I think I'm legally obliged to show you this slide as well. So these are sources.
Okay, you're going to stay with us for the whole day?
Yes, and tomorrow as well.
Okay, so you can meet Sebastian somewhere at the corridor and talk to him. So